In 1939, when every aviation expert in Britain was obsessed with fitting more guns, more armor, and more firepower onto the Spitfire, one RAF engineer proposed something that seemed absolutely insane. Strip out all the guns, remove the ammunition, take off the armor plating, and send these defenseless aircraft deep into enemy territory alone. His colleagues thought he'd lost his mind. The Air Ministry called it suicidal. Even Winston Churchill raised his eyebrows at the proposal. But this crazy idea would create a reconnaissance aircraft so fast, so high-flying, and so impossible to intercept that German fighter pilots would watch helplessly as these unarmed Spitfires photographed Hitler's most secret installations, and there was absolutely nothing they could do about it. This is the story of how removing weapons became the ultimate weapon, and how one man's counterintuitive thinking gave Britain eyes that could see into the very heart of Nazi Germany. September 1939. Britain has just declared war on Germany, and military commanders face an immediate, critical problem. They're flying blind. To fight a modern war, you need intelligence. You need to know where enemy forces are concentrated, where their factories are producing tanks and aircraft, where their U-boats are hiding, where they're building their coastal defenses. And in 1939, there was only one way to get that information: aerial reconnaissance. Someone had to fly over enemy territory, take photographs, and bring them back. But there was a deadly catch. The aircraft Britain was using for reconnaissance in 1939 were hopelessly outdated. The Bristol Blenheim, a twin-engine light bomber adapted for reconnaissance, could barely reach 260 miles per hour. The Westland Lysander, designed for Army cooperation, was even slower at 237 miles per hour. These aircraft were sitting ducks. German Messerschmitt Bf-109 fighters, by contrast, could reach speeds of 350 miles per hour. They could climb faster, fly higher, and turn tighter than anything Britain was sending over the continent. The losses were catastrophic. In the first months of the war, RAF reconnaissance aircraft were being shot down at an alarming rate. Crews knew that crossing into German airspace was likely a death sentence. Some pilots reported being chased by German fighters for miles, watching their instruments redlined as they pushed their engines to destruction, desperately trying to outrun the Messerschmitts closing in behind them. Many didn't make it back. The photographs they managed to capture, when they captured any at all, were often blurry, taken from too high an altitude in a desperate attempt to stay out of flak range, or incomplete, because the pilot had to break off the photo run to evade attacking fighters. Wing Commander Geoffrey Tuttle, who oversaw reconnaissance operations in early 1940, later wrote, "We were sending brave men to their deaths in aircraft that had no business being over enemy territory. We needed something faster, something that could outrun the fighters. But everything we had that was fast was a fighter itself. And fighters couldn't carry cameras. Or could they?" This is where our story's hero enters. Squadron Leader Maurice "Shorty" Longbottom. Longbottom was not your typical RAF officer. Before the war, he'd been an aerial photographer and surveyor, flying small civilian aircraft over remote territories to create maps. He understood cameras, optics, and the technical requirements of aerial photography better than almost anyone in the RAF. But more importantly, he understood something that the old guard of the Air Ministry didn't. In reconnaissance, survival was more important than firepower. In February 1940, Longbottom submitted a memorandum to the Air Ministry that would change the course of aerial warfare. The document was titled "Photography from High-Altitude Aircraft in War." His central argument was revolutionary. Instead of using slow, vulnerable bombers for reconnaissance, Britain should use its fastest fighter, the Supermarine Spitfire, stripped of all unnecessary weight to make it even faster. The best protection for a reconnaissance aircraft, Longbottom wrote, is not armor or guns. It is speed and altitude. An aircraft that cannot be caught cannot be shot down. Longbottom's proposal was specific and detailed. Remove all 8 Browning machine guns and their ammunition, saving approximately 450 pounds. Remove all armor plating protecting the pilot, saving another 90 pounds. Remove the gun sights, the gun camera, and all associated equipment, another 50 pounds. In total, nearly 600 pounds would be stripped from the Spitfire. Then, install cameras in the space where the guns used to be. Fit extra fuel tanks to extend the range. And send these unarmored Spitfires over Germany at speeds and altitudes that no fighter could reach. The response from the Air Ministry was mixed, to put it politely. Fighter pilots thought it was madness. "You want me to fly over Germany without guns?" one veteran Battle of Britain pilot reportedly said. "I'd rather parachute into Berlin and take photographs with a Brownie camera." Bomber Command thought it was a waste of resources. Spitfires were desperately needed as fighters, not as glorified cameras. Even some of Longbottom's colleagues in reconnaissance units were skeptical. The idea of flying deep into enemy territory with absolutely no means of defense seemed like suicide by another name. But Longbottom had one crucial ally. Air Chief Marshal Hugh Dowding, head of RAF Fighter Command, who understood that Britain was losing the intelligence war and needed something dramatic to change the equation. Dowding authorized a trial. 2 Spitfires would be modified according to Longbottom's specifications. The RAF's most secret experiment was about to begin. Heston Aerodrome, West London, March 1940. In a corner hangar, hidden from prying eyes, 2 Spitfire Mark Is were being transformed into something entirely new. The modifications were more extensive than most people realized. It wasn't just about removing guns and adding cameras. Every aspect of the aircraft had to be rethought for its new mission. The most obvious change? The guns came out. 8 Browning 303 machine guns, their ammunition belts, their feed mechanisms, their blast tubes, all removed. The wing leading edges, previously peppered with gun barrels, were faired over to create smooth surfaces. This alone reduced drag significantly. The cameras were installed in the wings and fuselage. Initially, they used f/24 cameras with 8-inch lenses, capable of capturing images from high altitude. The cameras were mounted vertically, pointing straight down, and synchronized to trigger automatically as the aircraft flew its photo run. But the real magic was in the weight savings and aerodynamic refinements. With 600 pounds removed, the Spitfire's power-to-weight ratio increased dramatically. The Rolls-Royce Merlin engine, previously hauling around all that military equipment, could now dedicate all its power to speed and altitude. Additional fuel tanks were fitted, one in the fuselage where gun equipment had been, and later drop tanks under the wings. This extended the operational range from approximately 400 miles to over 1,500 miles. Suddenly, targets deep in Germany, previously unreachable, were within range. But perhaps the most ingenious modification wasn't mechanical, it was cosmetic. Traditional camouflage schemes for RAF aircraft used dark greens and browns on the upper surfaces, designed to blend in when seen from above against the ground. But reconnaissance Spitfires would be flying at extreme altitudes, 30,000 feet or higher, where the primary threat came from below, from fighters climbing to intercept them. Someone realized, at high altitude, against a bright sky, dark camouflage made you more visible, not less. The solution? paint the entire aircraft in shades of light blue and pale pink. Yes, pink. At altitude, during dawn and dusk, the sky takes on pinkish hues. A light blue-pink aircraft would blend almost perfectly into this background. From below, German fighter pilots would struggle to spot these Spitfires against the sky, buying precious seconds that could mean the difference between escape and interception. Later variants used even more exotic schemes, a pale Prue blue, photo reconnaissance unit blue, that made the aircraft almost invisible at high altitude. German pilots reported the phenomenon. They knew a reconnaissance Spitfire was above them. Their radar had picked it up, but they simply couldn't see it, even when looking directly at where it should be.
The Photo Reconnaissance Unit, initially called the Heston Flight after its first base, was established in secrecy. The pilots selected were unique. They weren't aggressive fighter jockeys looking for aerial combat. They were cool-headed, methodical individuals who could fly long missions alone, navigating with precision, taking photographs with scientific accuracy, and most importantly, avoiding combat at all costs. Flight Lieutenant Alistair Sandy Taylor was one of the first. Before the war, he'd been a civilian pilot who'd flown photographic surveys in Africa. He understood both flying and photography, exactly the combination the PRU needed. These pilots underwent specialized training. They learned precision navigation, how to operate cameras while flying, how to read maps at high speed, and, most critically, how to think like a reconnaissance pilot rather than a fighter pilot. The hardest thing to train out of them, one instructor noted, was the instinct to fight. When a German fighter appeared, every fiber of their being wanted to turn into it, to engage, to dogfight. But their job was to run, always run. Speed was their weapon, altitude their shield. The moment they turned to fight, they'd lost. November 18, 1939, the first operational mission. Flight Lieutenant Maurice Longbottom himself, the man who'd conceived the entire concept, climbed into the cockpit of a stripped-down Spitfire at Secline in France. His target, the German city of Aachen, just across the border. As he climbed to 33,000 feet, an altitude that would have been impossible with a standard fully loaded Spitfire, Longbottom felt the temperature plummet. At that altitude, even in the enclosed cockpit, temperatures could reach minus 40 degrees Celsius. His breath formed ice crystals on the canopy. But the view was extraordinary. From 33,000 feet, he could see for over 100 miles in every direction. Germany spread out below him like a vast, detailed map. He crossed into German airspace. No flak reached him. He was simply too high. German radar picked him up, and fighters were scrambled, but by the time they climbed to intercept altitude, Longbottom was already 15 miles away, his cameras clicking methodically, capturing image after image of German military installations, rail yards, troop concentrations. A Messerschmitt Bf 109 pilot spotted him, a tiny glint of pink against the blue, and pushed his aircraft into a desperate climb, engine screaming at maximum power. But the 109, with its full armament and armor, couldn't match the modified Spitfire's climb rate at that altitude. The German pilot watched, frustrated, as the reconnaissance aircraft pulled away, untouchable. Longbottom returned to base 4 hours later with 175 photographs of incredible clarity. The experiment was a stunning success. The success of those first missions led to rapid expansion. More Spitfires were converted. The photo reconnaissance unit grew from a handful of aircraft to dozens, and eventually to several squadrons. Bases were established across Britain and later in Malta, North Africa, and even in the Far East. The aircraft evolved through multiple variants. The PR Mark I was the initial conversion. Spitfire Mark Is with guns removed and basic camera installations. The PR Mark IV featured additional fuel tanks in the leading edges of the wings, extending range even further. These aircraft could reach Berlin from Britain, photograph the target, and return, a round trip of over 1,600 miles. The PR Mark VII flew even higher, reaching altitudes of 40,000 feet, where the air was so thin that pilots needed special pressure breathing equipment just to stay conscious. The PR Mark X and XI, built on later Spitfire variants with more powerful Merlin engines, could fly at nearly 400 miles per hour at altitude, faster than any German fighter could match at that height. Camera technology improved as well. The RAF developed specialized reconnaissance cameras with longer lenses, faster film, and automatic exposure systems that could compensate for the varying light conditions at different altitudes and times of day. Stereoscopic camera pairs were installed, allowing photographs to be viewed in 3D back at base. This gave the intelligence analysts the ability to measure the exact height of buildings, identify different types of vehicles, and even estimate the depth of trenches and fortifications. The Germans, of course, didn't take this lying down. Hermann Göring, head of the Luftwaffe, was reportedly furious when he learned that British reconnaissance aircraft were flying over Germany with impunity, photographing everything from military installations to his own private estate. He allegedly shouted at a staff meeting, "These arrogant British are making fools of us. They fly where they please, photograph what they want, and we cannot touch them." The Luftwaffe tried multiple countermeasures. They modified Bf-109s and FW-119s, stripping them of armament to create light, high-altitude interceptors, exactly what Longbottom had done with the Spitfire, but in reverse. These leichte, or light variants, could climb higher and faster, but even then they struggled to catch the reconnaissance Spitfires, which had a head start in altitude and speed. They developed specialized high-altitude engines with superchargers and pressure cabins. The Junkers Ju-86P bomber was modified into a high-altitude reconnaissance and interceptor, capable of reaching 42,000 feet. For a brief period, these aircraft posed a genuine threat, until the RAF developed the Spitfire PR Mark VI and VII, which could fly even higher. They improved their radar networks and developed better early warning systems, trying to give their fighters more time to climb to intercept altitude. But even with 20 minutes of warning, it was often not enough. The reconnaissance Spitfires were simply too fast. They experimented with rockets, hoping to reach the high-flying reconnaissance aircraft with long-range air-to-air missiles. These efforts largely failed. The technology wasn't mature enough. In the end, the Germans never truly solved the problem. Throughout the war, RAF reconnaissance Spitfires remained extraordinarily difficult to intercept. Loss rates for PR Spitfires were among the lowest of any operational aircraft type in the RAF, approximately 2 to 3%, compared to 5 to 10% for bomber crews and 4 to 6% for fighter pilots in combat. The crazy idea had worked beyond anyone's wildest expectations.
Summer 1940. Britain stands alone against Nazi Germany. Hitler is planning Operation Sea Lion, the invasion of Britain. Across the Channel, in France, Belgium, and the Netherlands, German forces are assembling: barges, landing craft, troops, tanks, artillery. Britain desperately needs to know where these invasion forces are concentrated, when they're ready to launch, and what routes they'll take. Bomber reconnaissance is too risky. The losses are unsustainable. But the new reconnaissance Spitfires can do what bombers cannot. Day after day, multiple times per day, PR Spitfires cross the Channel at high altitude, photographing every port, every river, every beach where invasion barges might assemble. Flight Lieutenant Tony Hill flew one such mission over Dunkirk, now occupied by the Germans. His photographs revealed massive concentrations of barges, hundreds of them, lined up in the harbor and along the canals. RAF Bomber Command received these images within hours and launched devastating night raids, destroying many of the invasion craft before they could even leave port. Another PR pilot, Flying Officer Gordon Green, photographed the French coast from Calais to Cherbourg in a single 5-hour mission, bringing back over 500 images that were analyzed overnight by intelligence officers. They identified not just military targets, but also patterns, tidal patterns, beach gradients, obstacle placements. This information would prove invaluable, not just for defense, but later when planning D-Day.
The intelligence from these missions was so valuable that Winston Churchill received daily briefings based on PR Spitfire photographs. He could see with his own eyes the disposition of enemy forces preparing to invade his country. When Operation Sea Lion was eventually canceled, Hitler turned his attention east toward the Soviet Union. The reconnaissance intelligence was one factor that influenced his decision. The PR photographs showed that British defenses were stronger than expected, and that RAF raids were destroying invasion barges faster than Germany could replace them. Britain remained untouched, in no small part because unarmed Spitfires had given commanders the information they needed to prepare.
May 1943. Another famous story connects to our reconnaissance Spitfires. You may have heard of the famous Dam Busters raid, Operation Chastise, where modified Lancaster bombers used Barnes-Wallace's bouncing bombs to destroy German dams in the Ruhr Valley. But what you might not know is this: before the raid could even be planned, the RAF needed detailed photographs of those dams. They needed to know the exact height of the dam walls, the water levels, the defensive positions, the surrounding terrain. PR Spitfires flew multiple missions over the Monet, Eder, and Sorpe dams, taking oblique photographs from different angles. The stereoscopic images were analyzed by specialists who could calculate dimensions to within inches. But here's the extraordinary part. The Germans never realized what these reconnaissance flights meant. PR Spitfires flew over all sorts of targets every day. To the Germans, a reconnaissance flight over a dam was just another reconnaissance flight, nothing unusual. They had no idea that British engineers were using those photographs to plan one of the most daring raids of the war. After the successful raid destroyed the dams, PR Spitfires returned immediately to photograph the damage. Images of the massive floods, the destroyed dams, the devastated valleys, these reached Churchill's desk within 24 hours. The same pattern repeated throughout the war. Reconnaissance before an operation, reconnaissance after to assess damage. The PR Spitfires were Britain's eyes, constantly watching, always untouchable.
June 1944, Operation Overlord, the D-Day invasion, is approaching. This is the largest amphibious invasion in history. Success depends on perfect intelligence, knowing every German position, every obstacle on the beaches, every gun emplacement, every minefield. In the months leading up to D-Day, PR Spitfires flew thousands of missions over Normandy and the French coast. But there was a problem. They couldn't photograph just Normandy. If the Germans saw reconnaissance concentrated on the Normandy beaches, they'd deduce that's where the invasion would come. The element of surprise would be lost. So the PR squadrons executed a brilliant deception. For every photograph taken of the actual invasion beaches in Normandy, they took 2 photographs of the Pas de Calais area, where the Germans expected the invasion to come. This 2-for-1 rule
meant that German intelligence analysts, studying the patterns of British reconnaissance, would conclude that Calais was the primary target. The deception worked perfectly. Meanwhile, the intelligence gathered from Normandy was extraordinary. Analysts created detailed terrain models, three-dimensional maps that commanders could study. They identified every German strongpoint, every artillery position. On D-Day itself, June 6, 1944, PR Spitfires were among the first aircraft over the beaches at dawn, photographing the initial landings. Throughout the day, they flew mission after mission, bringing back images that allowed commanders to direct reinforcements, identify German counterattacks, and adjust strategy in real time. Flight Lieutenant Keith Truscott flew 3 missions over the beaches on D-Day alone, dodging flak and fighters, photographing the chaos below. His images showed that the landings at Omaha Beach were in trouble. German resistance was fiercer than expected. This intelligence helped commanders rush reinforcements to that sector. In the weeks after D-Day, as Allied forces fought through the Normandy hedgerows, PR Spitfires continued their work, identifying German tank concentrations, photographing bridges and rail lines for bomber targeting, tracking German retreats. One pilot later said, "We were the eyes of the entire invasion. Every decision, every bombing raid, every attack, it all started with photographs from our aircraft. And the Germans could do almost nothing to stop us."
The story wasn't limited to Europe. PR Spitfires also served in the Mediterranean, North Africa, and even in the Far East, where they operated in some of the most challenging conditions imaginable. In Burma, PR Spitfires faced not just Japanese fighters, but also brutal tropical weather, monsoons, violent thunderstorms, oppressive heat that affected engine performance. Yet they continued their missions, photographing Japanese positions in the jungles, tracking troop movements along primitive roads, identifying supply dumps hidden under jungle canopy. The aircraft had to be modified for tropical operations, dust filters for the engines, survival equipment for pilots who might be shot down over jungle, additional navigation equipment for missions over featureless terrain. In one remarkable mission, a PR Spitfire photographed the entire Thai-Burma Railway, the infamous Death Railway built by Allied prisoners of war. The images revealed not just the railway itself, but the horrific conditions of the POW camps along its route. This intelligence helped post-war tribunals prosecute Japanese war criminals. Throughout the Pacific Theater, everywhere the British operated, PR Spitfires provided the reconnaissance that made victory possible. By the end of World War II, the photo reconnaissance units had flown over 60,000 operational missions. They had taken more than 10 million photographs of enemy territory. The loss rate remained extraordinarily low. Approximately 250 reconnaissance Spitfires were lost in combat over the entire war, a rate of less than 3%. Compare that to Bomber Command, where in some operations, loss rates exceeded 50%, or to fighter squadrons where pilot losses were devastating. The reconnaissance pilots flew alone, unarmed, deep into enemy territory, yet they had better survival rates than almost any other operational role in the RAF. Longbottom's crazy idea had proven to be the safest as well as the most effective. The concept revolutionized military reconnaissance worldwide. The Americans adopted the idea immediately, creating their own unarmed reconnaissance variants of the P-38 Lightning and later the P-51 Mustang. These aircraft used the same principles: strip out weapons, maximize speed and altitude, avoid combat. The Germans, despite their initial failures to counter the reconnaissance Spitfires, also developed specialized reconnaissance variants of their fighters, though they never achieved the same success as the British. After the war, the reconnaissance Spitfire's legacy lived on in the design of dedicated reconnaissance aircraft, the English electric camera,
the Lockheed U-2, the SR-71 Blackbird. All these aircraft embodied the same philosophy. Speed and altitude are better protection than armor and guns. The U-2, famously, carried no weapons at all, just cameras. It flew so high that interception was nearly impossible. Sound familiar? The SR-71 Blackbird could fly at Mach 3, so fast that if a surface-to-air missile was launched at it, the standard procedure was simply to accelerate and outrun the missile, just as the PR Spitfires had outrun German fighters 30 years earlier. But beyond the technology and strategy, there's a human story here. The pilots who flew these missions were a special breed. They didn't get the glory of fighter aces or the recognition of bomber crews. They flew alone, often for 4 or 5 hours at a stretch, in freezing temperatures, with no weapons, no support, no wingman to watch their back. Many of them never fired a shot in anger during the entire war. Their battles were against altitude, weather, navigation errors, mechanical failures, and the constant psychological pressure of flying alone over enemy territory. Flight Lieutenant Alfred Warbury became one of the most decorated reconnaissance pilots of the war, flying over 350 missions from Malta. He photographed Italian and German targets across the Mediterranean, providing intelligence that led to the sinking of numerous Axis supply ships. Squadron Leader Gordon Hughes specialized in extremely low-level reconnaissance, the opposite approach, flying at 50 feet instead of 30,000 feet, using speed and surprise instead of altitude. He photographed the French coast before D-Day by flying so low and fast that German gunners couldn't track him.
Many pilots never came home. Some were shot down by the lucky German fighter pilot who happened to be in the right place at the right time. Others disappeared over the ocean, ran out of fuel, or crashed in bad weather. But their contribution to victory was incalculable. Every successful bombing raid depended on their reconnaissance. Every invasion, every battle plan, every strategic decision, all based on photographs taken by these unarmed Spitfires. In 1940, Squadron Leader Maurice Longbottom proposed something that seemed absolutely mad: remove the weapons from Britain's best fighter and send it over enemy territory defenseless. His colleagues thought it was suicide. The Air Ministry called it wasteful. Fighter pilots thought it was cowardice. But Longbottom understood something profound. Sometimes the best weapon is no weapon at all. By stripping out the guns, removing the armor, and maximizing speed and altitude, he created an aircraft that was more survivable, more effective, and more valuable than any armed fighter in the RAF's arsenal. The Reconnaissance Spitfire couldn't shoot down enemy aircraft, it couldn't bomb enemy targets, it couldn't fight. But it could see. And in war, seeing, knowing where the enemy is, what he's doing, what he's planning, is more valuable than any amount of firepower. The Germans never solved the problem. They tried lighter fighters, better engines, rockets, radar. Nothing worked. The Reconnaissance Spitfires remained untouchable, flying where they pleased, photographing what they wanted. From the beaches of Normandy to the dams of the Ruhr, from the ports of occupied France to the jungles of Burma, these unarmed aircraft shaped the course of the war. They were the ultimate proof that sometimes the craziest idea is the one that works. The next time someone tells you that removing your weapons makes you vulnerable, remember the Reconnaissance Spitfire. Because the Germans remembered it every time they watched helplessly as a pale blue shape disappeared into the clouds, untouchable, unstoppable, and unarmed. Sometimes the best defense isn't a shield or a gun. It's being too fast to catch. If you enjoyed this story of British innovation and ingenuity, make sure to subscribe to our channel for more untold stories from World War II, told from Britain's perspective. Next time, we'll explore how British engineers developed a secret weapon so bizarre that even Churchill didn't believe it would work until it destroyed Hitler's most protected targets. Hit that subscribe button, and I'll see you in the next one.